I'm going to power up and look at this little OCXO 10 megahertz unit. This I got from SURVY 2014 on eBay. Was about $25. Now the OCXO is an oven-controlled crystal oscillator. It's not just an oven-controlled crystal, and actually it's a controlled oven with a crystal and the oscillator circuitry to generate the output signal inside an insulated metal can. The idea of the controlled heating element is to maintain a more or less constant environment for the crystal. Here's a summary of different crystals or crystal oscillators. It runs from pretty poor accuracy to an atomic clock, which is extremely accurate. The relative accuracy of the OCXO, depending on its quality, is 1 part in 10 to the 7th or 1 part in 10 to the 9th. You see, there's quite a bit of difference there. So the quality of this little device makes a big difference. I've got this little 10 megahertz oscillator powered up. Now, I looked up this oscillator itself, just the metal can. They are available used on eBay for like $1.50 a piece or $1 a piece. And they're advertised as having a square wave output. Here are the crystal pins, here and here, and here, here, and here. This is the output. And it goes through a capacitor. Then it goes into a 2-pole low-pass filter. These 3 capacitors go to ground. These 2 inductors are in series, so to speak. And then it goes through another capacitor. Then the output of that capacitor goes to the SMA connector, right there. So they're actually shaping this square wave into some semblance of the sine wave by removing the harmonics. I've had this powered up for 24 hours. This more or less raggedy-ass square wave is the output for my QRP Labs satellite referenced standard. This moving sine wave is the output of the... If I adjust the trimmer of the little oscillator, I should be able to get this slowed down. By slowed down, I mean in comparison to this totally stable upper trace. Now if I go past 0, it'll start moving in the opposite direction. So I'll back it up a little bit. So the trick here is to finally adjust that potentiometer or trimmer until the 2 are stationary relative to each other. Now what I'm doing is triggering off of the upper one. The lower one is not involved in triggering, it's just being displayed. So the trigger puts this signal stationary. The untriggered signal is free to run. Now the idea is the peaks don't have to coincide. It's the movement that we're trying to minimize. So this is May 11th, that's a Tuesday. I'm going to just let this set up exactly the way it is. I'll come back in about 24 hours and we'll see where we are. I aged this for about a month. Checked it every couple days. It seemed to drift around 10 megahertz by maybe 2 hertz, plus or minus. Now I did have it on a 5-volt wall wart switching supply. I intend to test it more thoroughly on a linear supply. I intend to put it in a case, and to that end I've chosen this little plastic case. I want to follow the oscillator with a buffering amplifier, and I intend to use this. Now, a couple of weeks prior to this video, I did a build on this. This was a kit. I used this oscillator actually as an input to test the kit. Now, this is 5 volts. This wants to be 12 or more volts. This can draw right upon startup, and until this thing achieves temperature internally, about a half an amp. This thing draws less than 100 milliamps. So I plan on powering the whole box with 5 volts. And then, in order to derive from the 5 volt supply a plus 12 or more supply, I thought I would use its boost converter. And to that end, I did a drawing of the enclosure with these things mounted in the enclosure. Then on the same sheet of paper, I printed a drilling template for the front panel and a final template for the front panel. The amplifier kit came from this fellow, who I believe was in Turkey, if I'm not mistaken. And it was pricey. It's about $40 US. Now that's a kit. You have to wind the toroid and put all the pieces in place. The boost converter I got on eBay, $14. And it can take the 5 volts input to the device and up it to 5 to 40 volts. I'm not exactly sure what voltage this amplifier will stand. It has a 35 volt electrolytic capacitor on it. But I'm sure 24 volts is going to be more than enough. I'll prep to accept these devices, drill holes, mount them, drill the holes in the front panel, and then put a final front on it. And in part 2 of this video, I'll show you the completed construction, maybe step-by-step construction. It won't be too detailed. And then I'll continue with final testing and setting of the frequency. Now the OCXO that we have on that little board has a couple of ground pins, a power pin, and an output pin. It also has an input for a voltage reference. And using this reference voltage, I can vary the actual output frequency around the nominal 10 megahertz.